All right, if you're a multi-cloud architect, you know you're dealing with the invisible threads holding everything together, APIs. But what happens when those threads are less like steel cables and more like a house of cards? Today we're going to dive into how you can build real API resilience and stop catastrophic failures before they ever start. Let's get into it.
Just think about that for a second. It's the kind of thing that keeps architects up at night, right? One team makes what they think is a tiny change over in one cloud, and suddenly, boom, a chain reaction of failures lights up across the whole system. And look, it might sound a little dramatic, but this is a terrifyingly real possibility.
And that's the real danger here. This isn't some loud, obvious bug that screams at you from the logs. No, this is a quiet breakdown in communication between your services that just creeps into production, and you often have no idea it's even there until your customers start blowing up your support lines.
So to stop this kind of silent killer, we've really got to understand where things are actually breaking down. Let's walk through a classic and unfortunately a super common scenario.
Welcome to what I call the multi-team minefield. You've got Team A over here, and they push what they think is a small, harmless improvement. But what they don't realize is they've just changed the structure of the data their API sends out. At the same time, Team B's service, which totally depends on that data, suddenly starts crashing and burning. And the worst part, Team A has no clue they caused it, and Team B is stuck hunting for a ghost in their own code. This is just siloed chaos, plain and simple.
So the root cause here isn't actually bad code. It's a broken promise. See, there's this unspoken agreement, this kind of implicit handshake between these two services about how they're going to talk to each other. And when that promise gets broken, the whole thing just falls apart.
So the fix? We have to take that implicit, unspoken agreement and make it completely explicit. We have to define this invisible contract that's supposed to be governing our services.
And that, right there, is what an API contract is all about. It's a formal agreement written down between an API provider and anyone who uses it. It defines very clearly the exact structure of requests and responses. It turns that unspoken promise into a documented standard that everyone can see and, more importantly, rely on.
Okay, so that is the million-dollar question for any architect trying to build a system that doesn't fall over, right? How do we take this idea, this understanding, and turn it into a concrete set of rules that isn't just visible, but is automatically enforced?
Well, the answer isn't some single magic tool you can buy. It's actually a two-part strategy that combines having clear rules with having automated ways to check them. The whole solution really rests on two fundamental pillars.
First up, we've got schema governance. Think of this as your single source of truth. It's your open API spec, your GraphQL schema. It's the official document that describes your API structure. The second pillar is contract testing. This is where the apps using the API get to define tests that prove the provider is holding up its end of the bargain, making sure their specific needs are always met.
So here's the crucial takeaway. Governance sets the official rules of the road, but testing is what automatically proves that everybody is following those rules every single time a change is made. They work hand in hand. You really can't have one without the other.
Okay, theory is great and all, but what does this actually look like day to day? Let's walk through a real-world example and see how this whole process actually prevents an outage. So let's take a super common request, one you've probably heard a million times. A product owner comes to you and says, hey, we need to add the user's email to the profile endpoint. Now, without the right process in place, that simple request is a potential landmine.
So here's how you do it without fear. Step 1, and this is absolutely critical, you update the schema first, not the code. You propose a change to the official contract to add the new email field. Step 2, your CI/CD pipeline automatically kicks in and runs all the contract tests from every single consumer against that proposed schema change. Now, since just adding a new field doesn't break anyone who isn't looking for it, all the tests pass. And only then, at step 3, does the provider team get the green light to actually deploy the code with the new field. Finally, all the other teams can see the updated contract and they can decide to use that new email field whenever it makes sense for them. No pressure, and most importantly, no breakage.
And this visual just shows you exactly why this works so beautifully. A consumer that was built against schema version 1. It only cares about ID and name. So when it gets the new payload from schema version 2, it still gets the ID and name it expects. It just ignores the extra email field it doesn't know about. The contract for that existing consumer is still perfectly honored.
And that's the whole game right there. This is the core principle of evolving your APIs safely.
You make changes that are additive, not destructive. You expand the contract without ripping up the old terms. This way, backward compatibility is baked right into your process, not just something you hope for.
You know, when you adopt this approach, you basically get some new superpowers as an architect. You are now directly preventing production outages from API changes. You're giving your teams the autonomy to innovate confidently because they know there's a safety net. And what does that mean? It means you ship features faster and safer. You're not just managing APIs anymore, you're building a truly resilient, evolvable architecture.
So, I'll leave you with this question to think about. In your complex, multi-cloud world, when a team makes a single change, is your architecture a fortress that stands strong? Or is it a house of cards, just waiting for the wrong breeze to knock it all down? The difference, really, is having that explicit, enforceable contract right at the heart of your system.